hey to whoever needs this. I'm pretty sure most of the class needs this. I'm not sure if most of the class will actually watch this. But for those of you who are interested, this is a basic overview of coordinate geometry. Now, I have all the equations to deal with whatever we're doing on the right hand side, and I won't be going through too many questions or anything like that, but I'll be showing you the main things to do with lines and stuff like that, because we have to know a few things for exam that we have not touched whatsoever. No shade being thrown here. Okay, so first thing we have to understand is what the equation of a line means. The equation of the line is always written in the standard sort of format of y is equal to mx plus c, where y is like your y coordinate, m is your gradient, which is like the ratio of x to y, x is your x coordinate, and c is your y intercept. Now you could think of this as sort of like, I have here this with a few different sliders, so as m gets higher and higher and higher, it gets more and more steep. If m is negative, you could see it actually goes backwards, so the line goes backwards. And c just sort of pushes your line up and down. It's almost like putting your line on a table or offsetting your line. And y is equal to whatever that is sort of like a ratio. So if you had y is equal to x, then m would be 1, c would be 0. So y is equal to 1x, so y is equal to x plus 0, which is the same as x. You just have a line where like 2, y is equal to 2, x is equal to 2, y is equal to 4, x is equal to 4, y is equal to 3, x is equal to 3. That sort of thing. And then depending on how it changes, that'll change how your line looks. Now, the equation of a line, like assuming, let's say you didn't get all this stuff, like it didn't load up nicely here and you can't see what your line looks like. And all you need for your line is a point and a gradient for the equation of your line. So let's say we had a point 2, 3. I'm just really choosing a random point. I didn't think this through very much. And let's say your gradient is 2. Now I'll be doing all my calculations off of this screen because I really can't be bothered to edit this. Not that I can't be bothered, but it'll take ages, and it doesn't make any sense that I give you all this stuff and it's at like 11 o'clock in the night. So if you use the equation on the right, which is y minus y1 is equal to m into x minus x1, where y is just y, y1 is whatever your coordinate is, so in this case it's like the 3 here. M is your gradient, which you said the gradient is 2. Let me just like write gradient is 2. Probably give you like a whole new error for this. Yeah, I'm not supposed to write that there. And x is just x, and then x1 is your x coordinate, so it'll be like 2. So it'll be y minus 3, because we're substituting all those values into it, is equal to 2 into x minus 2. So that'd be y minus 3 is equal to, now you multiply everything by 2 because it's 2 by everything in brackets, 2x minus 4. So y is equal to 2x minus 4 plus 3. Bring the 3 across the equal sign. Y is equal to 2x minus 1. So that would be your equation of your line. And let's say we put this in here. Oh, wrong place. I don't use this very much. So let's say y is y, x is x, so that would be 2x minus 1. Yeah. So that's your line. I should actually just put this over here. Y is equal to 2x minus 1. And you see, it passes through that one point, and it has the gradient we want. So that's how you use that equation. Next thing you want to use, and let's say, okay, let's call this point A. Because, oh yeah, let me put that up there. We're calling 2, 3 point A. And let's call another point, because I'm uncreative, it's going to be 4, 5. Can you tell where I got my inspiration? Point B. Now you see, now this equation doesn't line up because this gradient isn't 2, if that makes sense. So I could take that off now. So let's call this B. Let's call this one A, right? And let's call this one B. So we have 2 points, A and B. And the next thing we have to look at is finding the midpoint of A and B. So, like, if you remember average is sort of like the midpoint of two things. So let's say you had the average of 5 and 7. It would be 5 plus 7 is 12 divided by 2, because that's the amount of numbers. It would be 6. The same thing sort of applies for coordinates. So, using the midpoint of line equation on the right, you could see XA. By the way, those little letters and stuff underneath it, like the sort of ones below, they don't actually really mean anything in terms of calculating anything. I just put it there so that I don't forget where to put my numbers. And like, if you mix up where you're putting your numbers, that's a good way to tell, because when you write it down, you'll see where you should have put everything. So it'll be XA plus XB over 2. And then YA plus YB over 2. In this case, the x-coordinate of A is 2, plus the x-coordinate of B is 4 over 2. And that would, the y-coordinate of A is 3, plus the x-coordinate of, the y-coordinate of B is 5 over 2. So you'd end up with 6 over 2 and 8 over 2. If you want, you could follow at home with your paper if you don't see it. Like, if you can't see the equation playing out. So that would mean that your x-coordinate of your midpoint is 6 over 2. Your y-coordinate of your midpoint is 8 over 2. So that would reduce to like 3, 4. So if I put 3, 4 here, you notice that it's a point in the middle of these two lines. Like right in the middle. And that's how you use the midpoint equation. Next thing. Now, we want to find out what's the gradient of this. Because, like, as I said, we changed the gradient when we chose another point. Oh, I'm using scrap paper. I shouldn't be using this. It was something important. So, we have enough points. Like, let's assume we didn't have this one for now. Let me just delete that. Pretend this isn't there. Yeah. You could use the 2 point. I mean, we could use the 3rd point, but you don't need to. And now we want to find the gradient of this line. The gradient of a line is equal to YB minus YA over XB minus XA. Again, B and A aren't really just for this, like, are really just for this, because if they give you 2 points, like let's say it's point Q and point P or something like that, you just change the thing. It just so that you know where you're putting your thing. So the y-coordinate of B, in this case, is 5, minus the x-coordinate of, minus the y-coordinate of A, which is 3, over the x-coordinate of B is 4, and the x-coordinate of A is 2. So we end up with 2 over 2, we end up with 1. So in this case, our gradient is 1. So I've sort of chosen a 45-degree line here. But, So, let me show you one time. If I can put back M here because it's all on the same line. If I just made the equation back using one of these points. So you have 2, 3 now. So y minus y of A is 3 is equal to 1 into x minus x of A is 2. The x-coordinate of A is 2. So 9 minus 3 is equal to x minus 2. Y is equal to x minus 2 plus 3. Y is equal to x plus 1. So if we put the equation y is equal to x plus 1 here, you see it passes through all of these points. So we did a good job. Hooray! Oh, I'm rambling so much. I'm over time. Now, the next thing to note, and this is just something to note, You see it there. The gradient of a line perpendicular, so like at right angles to this line. So if I put the line back at right angles, like going this way to this line, is equal to -1 over whatever the gradient is. In this case, our gradient is 1. So -1 over 1 would be equal to -1. So this brings us, I don't speak a lot at the same time to myself, which is why I'm coughing. So this quickly brings us to the last thing, which is the gradient, the equation of the perpendicular bisector of this line. So you know the midpoint, so that's the thing that bisects it, if that makes sense. The bisecting part is where it cuts it in half, and that's the midpoint. And then, so that is the point you have on the perpendicular bisector, and you also have the gradient, which is -1. So if you use the same equation, y minus, in this case, we're using the midpoint because we want to get the perpendicular bisector, the bisector. So y minus the y coordinate of the bisector is 4 is equal to -1 into x minus, the x coordinate is 3. So it's y minus 4 is equal to -x plus 3, because negative by negative is a positive. Y is equal to -x plus 3 plus 4, y is equal to -x plus 7. So now, if we do that and put it in here, y is equal to -x plus 7, we get the equation of a perpendicular bisector of the line. Hooray! Okay, that's pretty much all there is to know. The last thing to know, and just to note, like, if you get two equations like this, and you solve them simultaneously, like I could use these ones for an example. I'm running out of paper here. Oh, let's scribble all of my physics stuff. Chaos. In this case, we have y is equal to x plus 1, call that equation 1, and y is equal to -x plus 7, call that equation 2. So, if you subtract them, in this case, you would get 0 is equal to x minus x is 2x, 1 minus 7 is -6. So 2x is equal to -6, x is equal, no, 2x is equal to 6, sorry, because you carried over the equal sign. X is equal to 3. Then you put 3 back in one of these equations. So y is equal to 3 plus 1 using equation 1. Y is equal to 4. And so you get the coordinates 3, 4, which is the midpoint of your line. Which means that's the point of intersection of this line and this line. Like, if you didn't see this, if it wasn't there, and you solve this line with this line, you would find this point. Hope that makes sense. And I hope this helps somewhat. Next thing I'm going to be doing is quadratics really quickly, just to introduce you to the whole idea of this. Okay, let me get this up really quick so you guys can start. Bye.